Good morning. So first video is going to be meanders and their formation, and then Oxbow lakes. And there's quite a lot to meanders, so bear with me. So usually, again, if you were to draw a characteristic river, you would probably draw a nice straight river of water flowing in one direction. And rivers kind of start off flowing in a straight direction, but something makes them bend. And you see, if you've seen aerial photographs of rivers, they kind of like bend and snake all over the place like this. And it's these sinuous meandering bends that we call meanders. And they form in a very particular way. So whenever we get a nice straight river, at some point in time, for some reason, there'll be areas which have like more pebbles or just more bits of sediment and rubble at the bottom of the river, which will make it shallower. And there'll be some bits where there aren't as much sort of, these pebbles and shingly bits, and you'll get deeper areas of water. We call this a pool and riffle sequence. So your riffle bit is your bit where you've got lots of sediment, so it's shallower. And we sit with riffle like that. And then so it's meant to be an E. And the bits that are deeper we call pools. So what tends to happen with the river is it will avoid the riffles, because this is going to slow it down. It's going to cause friction between the pebbles and the water and slow the water down. So it will try and, if it can, avoid the riffles. And it will therefore try and go to the pool areas, which are much deeper. It's easier for it to flow. So what you end up with over time is, how can I'll take that off for the minute. Is you'll end up with, say, a series of pools, a series of riffles, and what the water will then try and do is it will just try and work its way around the riffles and through the pools. So it might flow a little bit like this. So it will try and avoid these riffles and it will try and go through the pools. So what it does, therefore, is it starts to kind of bend. And then you'd end up with a river that looks a little bit like this. So these will be your deep pools, and these kind of bits in between where it's not as bendy might be your riffly sections, like that. So it will always bend towards these deeper parts. And if you imagine the water is now travelling along here, it will again always bend towards the deeper parts, which means you're going to get significantly more erosion on this section. Wherever you've got deeper water, you've got less friction, so you're going to have more energy. So what tends to happen, and again, so it goes back to a term that we started using last lesson, is we get more lateral erosion. So here and here, we're going to get more sideways erosion, because the force of the water is going to come down here and hit against this riverbank here and against the riverbank here. It will, as it gets bigger and bigger as well, also sort of cause some vertical erosion, because there's bits of pieces of debris and sediment in the river. So that'll also cause abrasion on the bottom and abrasion against the sides of the riverbank. So you'll get mostly lateral erosion, but also a bit of vertical erosion down as well, making those pools even deeper and making these bends even more emphasised. So you imagine if all the erosion's happening here and here, over time this bank is going to move, isn't it, in that direction. And can you see it's going to get even more windy? So again, the next stage in our diagram is kind of going to be even more meandery, like this. And again, our deep pools are going to be over here. Our river is still going to concentrate its energy in those deeper bits. If we were to draw the line of the fastest bit of the river, it would kind of go on the outside of all those bends as it gets to the deeper parts. Just to add another key term in here, pathway 1 and 2 need to know this one. The fastest flow of the water is called the thalweg. So if you were to draw on the fastest flow, which is the bit that hits these pools on the outsides of these bends, that is called the thalweg. It's a nice keyword for you to have. Another keyword I forgot up here, sorry, is when we get this flow that goes either side, so it kind of starts to meander, we call this flow helicoidal flow. And that just means it kind of flows from one side to the other. But that's what's really important, because that's what starts this whole sequence of erosion off, and that's what ends up giving us these large meanders. And over time, a river will go from being fairly straight, the helicoidal flow will kind of open up these bends and the meanders. It then becomes very winding and meandering as we go further on. So far we've talked about the erosion that happens, but we haven't talked about the deposition. We looked at erosional landforms last time. These are the erosional and depositional ones. So we said the fastest flow of the river hits the outside bends. So you can probably guess where it's going to have, therefore, the lowest flow. So if this bit's the bit here where all the energy is being concentrated on the outside of the bend, that's where all the erosion is happening. Over here is going to be really nice and sheltered. So what you'll end up having on this side of the bend is a nice build-up of sediment and sand and stuff like that. And again, you get the same one here. Hence you get erosion and deposition. It's an erosional and depositional landform. Again, you need to know some of the key features that we have in meanders. So obviously the winding, bending is obviously one key feature. This bit here, where we've got lots of the erosion, if you imagine going to stand there on the riverbank, there'd be, the erosion is so great here that actually what you get is a bit of a river cliff. So let's put river. And that can be quite high and quite steep. It can be quite vertical. It's because all this land is being eroded quite fast by the water. So on the outside of the bends, you're going to get these river cliffs. And on this side, we call the area of deposition a river beach. There's other terms for them too. Some people call them slip-off slopes, river beach or slip-off slope. Either way, that area of deposition is there as well. The other thing we now have to do, so if you want to draw these diagrams down, perhaps pause the video because I'm going to get rid of it now, is they could ask you to draw the sequence of how a meander flows or expect you to label it or something like that. They could also expect you to draw a cross section. So if we were to take our really big meander like that and do a cross section, again a little bit like we did with the long profile the other day. So if we said we're going to cut the river through from A to B, here to here, on the outside bend of the meander, we want to see what that looks like in real life. So again, if we draw an A and a B over here to represent it, we said on the outside bend over here, let's draw it back on again, we get a big deep pool. So we're expecting, if we cut a river in half, for this side near A to be deeper, and it is. So if we were to draw it, there's our sort of side of the riverbank. Then we have almost a vertical, big, deep section over here, where we've got our river cliff. Put a bit of river there. And then, as we go over to B, and we said this is the area over here, near B, where we've got this river beach, we've got this area of deposition. So we're going to get much, much shallower over here to B. And of course up here we'd have some nice sort of depositional material. Let's just draw that on, there we go. And we would have our river beach. And of course you can draw your river on as well if you want to. So river cliff, almost vertical. It can be undercut as well, because remember, you've got at the bottom of here lots of bits of sand and pebbles and stuff. As the water's flowing, it's going to pick these up, it's going to hurl them at the side, and it could even undercut. So you could even kind of draw an undercut section, your river cliff as well, if you wanted to. And again, remember the types of erosion we've been talking about. So try and get keywords in there when you're describing. If it's picking up little pebbles from the bottom and it's hurling them against the side, that'll be abrasion. If it's just the sheer force of the water hitting the sides, that's going to be hydraulic action. So try and get some of those key erosion terms in there too. I think we've pretty much covered everything we need to with meanders. So we've looked at the actual meander sequence, how they form, the pool and riffle sequences, the helicoidal flow where it starts to meander in the first place. We talked about the Thowaweg, the fastest flow of the water, and we said what it will look like if we were to cut it in half and do a cross section, which is our bit there. You should be drawing both of these sets of diagrams, so the sequence formation and the cross section, because again in the exam they could ask you for either or both. So on to Oxbow Lakes. I'm sure you've all heard of them. I know whenever I ask anybody or tell anybody I'm a geography teacher, they go, oh, Meanders and Oxbow Lakes. It seems to be the one thing that they seem to remember. I don't quite know why. So we know that our river goes from being quite straight to being quite meandery. A really good word for meandery or bendy is, sorry, sinuous. So if a river is bending, it's meandering, it's very sinuous. I like that word, don't know why. So when we get to a point where our meanders are becoming really, really sinuous, really, really pronounced like this, sometimes they're just so windy, they just can't carry on this anymore. So if, again, we're to draw on where our pools and well, most importantly, where our pools are. So our pools, our deeper bits where the fastest flow of the water is going to be on these outside bends. Okay, a nice big pool there too. And we get the most erosion whether we get these deep pools. So let's draw that just to show these bits are being eroded. Now, can you see when it becomes really, really sinuous, we've got two big sections down here which are both being eroded. Now, if you imagine this bit's being eroded, this bit's being eroded, it's only a matter of time really before they're going to join up. Now, normally we'll get a cutting off of a meander to form an Oxbow Lake when there's a big flood. So you imagine your Thalweg, your fastest part of your river, is coming down here, it's hitting all this down here on the outside bend and eroding it. If we've suddenly got a flood event and we've got a lot more water coming down here, it gets to this point here and there's only such a small distance, it's going to start to kind of flood over the sides of the bank. And all it takes is a little bit more erosion here and a little bit more power, a little bit more energy. And the river kind of goes, well, I can't be bothered to go all the way around that loop. There's a much easier way here. I'm just going to cut across. And that's what happens to form an Oxbow Lake. So during a period of flood, the river will just simply cut off this really, really windy, sinuous meander, and will just, during a time of flow and heavy flow and flooding, will completely cut it off. What tends to happen then is you've now got quite a straight section, so it'll almost revert to being a straight river again, and it'll go off, obviously off on its meanders over here somewhere, and the whole process will start again. This will be a straight section, it will become a little bit more of a pool and riffle sequence, and it will become a big meander again. It kind of works in a bit of a cycle, but this section here kind of then becomes redundant. It'll still have some water left in it because the water was flowing over here and it was during a flood, so this is kind of filled with water now. But what you tend to find is the water's now flowing really, really quickly down here. This bit over here might be quite sheltered. So we tend to find that we get a build-up of sediment over this side. And what eventually ends up happening is this just becomes a straight section of river and this just completely gets cut off. So if we were to kind of almost redraw this bit, our river's now quite happily going straight down here. It's built up a load of sediment over here, which has then kind of cut it off. And this section over here now looks like a very funny shaped lake. And of course, we're not going to have any erosion, we're not going to have any deep pools anymore, but this would all be filled with water. Oxbow Lake. Again, the remnants of what was there before will be left behind. So this will still be a river cliff. This will still be a much steeper bit. And yeah, okay, this bit might be a bit deeper. And again, you're still going to have the features of your meander, so you're still going to have a river beach over here too. So if you go and have a look at an Oxbow Lake that is newly formed, you'd still see a river cliff here, you'd still see a river beach or a slip-off slope over here, and you get this kind of C-shaped lake left behind. And that's it for Meanders and Oxbow Lakes.